Hi, so today I would like to discuss the pre-treatment with you. The pre-treatment of biomass is an important part of the biorefinery process, since it will liberate components that are trapped inside the cell. It is also an important first step that needs to happen before the chemical or biological conversion can be performed. We will take a closer look at two different types of biomass, which both require a different pre-treatment approach. First, I will discuss how to break open algal cells using mechanical techniques. And then later, we will explain the pre-treatment on a variety of lignocellulosic and green biomass, as well as how to obtain soluble sugars. So let's have a look at the algae pre-treatment approaches. On the left you see an intact Chlamydomonas reinhardti algal cell. As you can see, there are lipids, proteins and starch inside the cell, and we are interested in obtaining these compounds. But they are basically locked behind the cell wall matrix. So, in order to rupture this cell, we will have to use some force or energy in order to break this barrier. However, you should be careful that it is not too much energy, as this might result in the breakdown of the native structure of the proteins, greatly reducing the value of these components. So when you perform cell disruption on microorganisms, a wide range of techniques are available that can also be applied to algae. Basically, you could use a mechanical or a non-mechanical approach. There are a wide range of techniques that can be used, such as microwaves, ultrasonification, osmotic shock, or the use of pulsed electric fields. But for now, I will just focus on bead milling and high pressure homogenization. So what is bead milling exactly? Well, here you see a graphic representation of a bead mill. It is a reactor that contains several discs that are turning. The reactor is also filled with small beads. These beads usually have a diameter less than 1 millimeter, and because the discs are turning, the beads are mixed, which results in a large amount of collisions between the beads as well as a lot of shear. Now, the combination of shear and collisions with the beads will result in algal disruption. So at time is 0, the algae are intact, while after 1 hour, the whole algal broth is disrupted. Next to bead milling, you could also use high pressure homogenizers. The principle behind high pressure homogenization is a certain pressure difference between the nozzle and the outside environment. This will result in high shear forces when the algae suspension passes through the nozzle. And as a result of this, the cell walls rupture. So summarizing, what happened here? Well, for both the homogenizer and the bead mill, intracellular components will be released to the environment. However, be aware that there are some insoluble material left that will remain suspended in the liquid. These very small particles might hamper the separation steps that might come after the cell disruption step. So thank you for watching and good luck with the exercises.